Hey guys, welcome to another math video. For this one I'll be going over Binomial Theorem and Pascal's Triangle. So you can't really talk about one without talking about the other because they go hand in hand. And the Binomial Theorem would be talking about its application to algebra as opposed to its application in statistics. Okay, so this is what we'll be covering, just like I mentioned earlier. Okay, so Pascal's Triangle, if you haven't seen it, looks something like this. Alright, so start with 1 here, and to get each successive row, what we're going to do is we're going to add the numbers that you see from the previous row. So to get this value here, we're going to add the number that's above it on the right and the left. But since there's no number that appears here, there's nothing there, right? So in math, numerically, nothing is 0. So 0 plus 1 is 1, and same thing here, there's nothing here, so that's another 0. 1 plus 0 is 1. That's how we get that. So to get this row, we do the same thing. We add from the previous row. 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 0 is 1. Okay, next row, we use the previous row. So here, 0 plus 1 is 1. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 0 is 1, and so on, and so on, and so on for each successive row. Okay, now, each of these rows also represents the coefficients you would use, or the multiples you would use, depending on what exponent you've been given. So, the first row here would be when n is equal to 0, because anything to the power of 0 is 1. Exponent is 1, exponent 2, 3, 4, and 5, and so on, and so on, and so on. Alright, so I know this doesn't make too much sense right now, but once we combine it with the binomial theorem, it'll start to make a lot more sense. Alright, so here's the binomial theorem. Basically, it's just a binomial raised to some power. So here's that n that you saw on the last slide. And a and b represents your two terms. Okay, so this is how we use the Pascal's triangle with the binomial theorem. So depending on what your n is, that's the row we're going to be using. So that's all of your c's, okay, all your constants. So the first one starts with the first constant times the first term raised to whatever power you're using. Then you're going to take the second term, and this time for a, you're going to reduce the exponent by 1, and we'll multiply that to the b term. Then we'll take the next constant and multiply that to the first term, and we're going to keep decreasing its exponent by 1, and we'll keep increasing the exponent by 1 for the b term. We'll keep doing that until we get to the a term down to 1. Right, so the power of 0, and the b term to whatever n power we're doing. So I know this looks confusing right now, but once we get into the example, it'll make a lot more sense, trust me. Okay, so here's our example. We're going to use the binomial theorem and Pascal's triangle to expand x plus 3 squared. Alright, so in case you forgot, here's Pascal's triangle again. So our n is 2. So we'll be using this row right here, the 1, 2, 1. Okay, so the 1, 2, and 1 are going to be our c's. Okay, so c sub 1, c sub 2, c sub 3. Okay, so it looks something like this. So 1 times the a term, which in this case is x, to the n power, which is 2. Okay, next one was 2 times the a term with the exponent reduced by 1, so 2 minus 1 is 1, so just x, times the b term, which in this case is 3. Then we'll do 1 times, so once we're going to reduce this exponent by 1 again, so 1 minus 1 is 0, so anything to the power of 0 I mentioned earlier was 1, so we don't really have to put that in. And then we'll take our b term and increase its exponent by 1 from here. So this has an exponent of 1. 1 plus 1 is 2, which is our n. So we've reached our n power. So we're done setting up using the binomial theorem and Pascal's triangle. So all we have to do here is evaluate, and that's what we get. Okay, so I used something to the second power because it's something that's easy to verify that you can do longhand, and you should come out to this if you did it the long way too. Okay, so now let's try another example, but this time with a higher exponent. Okay, so we're going to do it with a binomial that has an exponent of 5. Alright, so here's Pascal's triangle again. So our n is 5, our exponent is 5, so we'll be using this row. These are going to be all of our c's. Okay. So the first setup will look something like this. Alright, so you notice these are our c's. Right, the 1, 5, 10, 10, 5, 1. Starting with the a term, which in this case is the 2x, raised to the n power. So this is important here because you want to raise the entire term to the to the power of n, not just the variable. Okay, so it's important that you put that parentheses there because that tells you that this exponent applies to the whole thing, not just to whatever it's attached to at the end. So if instead you did 2x to the 5th without the parentheses, it will look like only the x is. It will only look like the exponent is being applied to the x instead of the entire 2x. Okay, so the next term, we're going to reduce this exponent by 1, and we'll introduce the b term. Same thing for the next one. See, a term exponent is being reduced by 1, while the b term has its exponent increased by 1. And you keep going until the exponent for the a term is 0, and the exponent for the b term reaches your n. Alright, so now all you gotta do next is evaluate. So remember, in order of operations, exponents are, well, parentheses are first. But if there's stuff inside the parentheses, you want to work on that stuff first. Okay, so inside the parentheses, we got exponents, so you want to simplify that first. Then we'll take care of the multiplication, because we got some products in here. At the same time, I simplified these here at the end because anything times 1 is still itself. And then all we gotta do is finish off the multiplication, and that's our final end product there. So you can do this the long way by expanding 2x plus 3y to the 5th power, writing it out 5 times, and then foiling and distributing. But that's going to be way longer than if you did it this way. So of course, if the exponent's higher, you just keep going, building your triangle. And it's not very difficult to do. Alright guys, so that's pretty much it. So using Pascal's triangle and the binomial theorem is very helpful if you have a binomial raised to an exponent higher than 2. It's going to save you that much more time. Alright guys, well that's it for this video. Thanks for tuning in, and stay tuned for my next one.